my pleasure to introduce our next speaker, Dr. David Titley. Dr. Titley served as a naval officer for 32 years and rose to the rank of Rear Admiral. In 2009, he initiated and led the U.S. Navy's Task Force on Climate Change. After retiring from the Navy, he served as the Deputy Undersecretary of Commerce for Operations at NOAA and was a professor of practice in meteorology and atmospheric science and a professor of international affairs at Penn State. He was the founding director for Penn State's Center for Solutions to Weather and Climate Risk. So please help me welcome Dr. Titley to the stage.
Okay, thanks so much, Donna, for that kind introduction. Two things. One, I'm surprised you're all still here once I heard mention of a candy buffet, because that sounds pretty good, so congratulations, you have more willpower than I do. Second is, it's so nice to be doing these not on Zoom, at least for a little bit, so I appreciate that and sort of remember how to do these kind of things live again, which is way more fun. So, okay, with that, my plan is here, I'm probably going to talk 35, maybe 40 minutes, but probably no longer. And I would like lots of time for questions. Anything's on the game on the floor with respect to climate or anything really that you would like to ask, whether it's a science side, the applications, the where do we go from here. I'll take it. I will start off. All these views are mine personally. I don't work for the government in any way, shape, or form, be it NOAA, be it the Department of Defense, or anyone else. The good thing is I'm free to say whatever I want. The bad thing is it probably doesn't matter what I say. So, okay, with that, let me show you my introduction to emergency management. In the U.S. Navy, the headquarters for meteorology and oceanography is at a place called Stennis Space Center. It's actually a NASA base right on the coastline of the Mississippi, Louisiana. There's a big buffer zone because they used to test the Saturn V rockets there. So you either live in Louisiana, north of New Orleans, or you live along the Mississippi coast. And this is the house that I was living in. And probably in this audience, more than most, you have an idea of what a 30-foot storm surge does going up a street. This is me, and this is when I came back post-Katrina. The good news is I didn't have a lot of cleanup to do. But this is pretty much what the whole coastline looked like. So this was sort of my introduction to really extreme events, extreme where I would say the worst matters much more than the bad, and then sort of interacting with your profession and your community. So that's kind of sort of where I got started in this about, I guess now, 16 years ago. Okay, in the Navy, certainly in the DoD, we kind of have this idea of bottom line up front, right? So you don't want to wait for 35 minutes to figure out, did this guy actually say anything to me? So here's kind of the three things that I would say are kind of relevant to this. Is first, and you can read better than I can talk, so I'm not going to read them to you, but what we've done is probably not going to get us to where we need to go. It works okay if we had, kind of what we would call in the science world a stationary time series, or we're not really changing, but we're changing, and we're changing really quickly. The other part, which I think is important, is I would argue that we've had a lot of focus, especially in the preparedness, such preparedness that we do, is sort of on a business cost analysis. So that means if you're privileged and you have really expensive assets, it's going to look pretty good if you protect them. What about all those communities who don't have a ton of assets and kind of always get the short end of the stick? I would argue that maybe our focus should be, rather than on that Excel sheet, green eye shade, dollar cost analysis, we should really be thinking about the pain that people go through. And yes, we're going to look at assets, but we should also not forget people, especially those who don't have a lot and have a really hard time recovering from extreme events. Another point that I think is not always emphasized by let's say, politicians, because it's not a really convenient one, is regardless of what we do or do not do on the emissions side. So we have Glasgow coming up. We'll see what happens. Let's say the U.S. does drastically cut greenhouse gases by 2030, 2035. Let's say that happens. For your profession, and mine in meteorology, I would argue that not only for the rest of your careers are you going to see increasing extreme events, but all those young women and men who you are mentoring today and bringing into your field for their generation, we're still going to see extreme events coming up. And that's because we're out of balance right now. The Earth system, ocean, atmosphere, heat system is out of balance. So even if we get our foot off the accelerator, and our foot's still on the accelerator for greenhouse gases, it's going to take a while, and a while is decades, probably 2, possibly 3 decades, for the Earth to get back into balance. 2 or 3 decades on the scale of the Earth is not very much time, but on the scale of us and our careers, that's a lot of time. So the extreme stuff that we've been seeing in the last 5, 10, maybe 15 years, this is the good old days. This is the good old days. So not only you, but the next generation of emergency managers needs to realize it doesn't get any better than what it's been in 2018, 2019, 2020, 2021. That's kind of sobering. And I don't know that a lot of people talk about that, but that's where we're going. And then it's going to cost us. The Department of Defense is starting to be a little bit more honest about this. For a long time, it was like, well, we're going to make these investments, and it's going to be wonderful, and everybody's going to bring unicorns into work, and it's just going to be great because we're all going to be green, and everyone's going to love it. Sorry, guys. Okay, here's a little reality check. This is going to be expensive, and not everybody's going to be a winner. Okay? And those are going to be hard things for politicians and political decisions to deal with. And it's going to be hard for the country. And we're going to have to, in my personal view, factor equity and justice into this along with everything else that was already hard even before we started to have those conversations. So that's kind of the 3 things I would like you to leave you with. I'm going to go through how I think of climate change, and it's not Keeling curves, it's not tons or gigatons of carbon dioxide. It's 3 things, because I'm a simple person, I can only do 3s. People, water, and change. This is really fundamentally about us. It's not about polar bears. If we actually cared about polar bears, we would have fixed this a long time ago. We haven't. It is about us, and we'll see how much we care about people. And it's starting to affect people closer and closer and closer to us, including sometimes ourselves. That might, keyword might, spur some action off top dead center. Water is a pretty good integrating principle. It is driven by heat. I'm not going to bore you with the science, but I'm sure just about everybody in here knows that as you warm up the atmosphere, the water vapor cycle actually supercharges. It goes up more than linearly. It actually starts going up exponentially. And this is one of the reasons that we have seen these just incredible rainfall rates time and time and time again now in the last 3 or 4 years, not just in the US, but really globally. And that then leads to we've never seen this before. It's not in our plans. We don't know how to, we're in total response mode because we never thought about this. And you can use the old 9/11 saying of failure of imagination. It's coming. What I've been saying about water for a long time is, too much, too little, wrong place, wrong time, salty where it used to be fresh, wet where it used to be dry, liquid where it used to be solid. And even actually the chemistry of the oceans is changing, but we're not going to probably talk too much about that today. But water is a pretty good integrating principle. And then finally, the part about climate change. We've had climate. Who here is from San Diego or Honolulu? Probably a couple. Okay, 1, 2. You folks, you have pretty much ideal climate. All the rest of us, I'm from central Pennsylvania now. Come up here in November. or even Michigan, right, on this side of Lake Michigan. Nobody's going to claim we have ideal climate, but we did have a climate that we knew what to expect. So the part that really concerns me is not the climate piece of climate change, it's the change piece. And we're changing the climate as fast as we've probably ever seen in millions or even tens of millions of years on the Earth. So that then pushes us into different places. Will the Earth survive? Yes. The Earth will be just fine. But how much pain we have on ourselves, not to mention inflict on the other ecosystems, is the open question. And oh, by the way, this is probably the best tip jar I've ever seen. It was in Monterey Coffee House. I kind of like that one. Okay, so those are my three things. Okay, so it's going to cost us. We're going to have more extreme events, and we are going to, and there are going to be losers in this. And people water change. So let me go through some of the basics. If you've seen some of the science stuff, it's like, yeah, okay, I've seen this stuff. Maybe, but not everybody has. So I'm just going to go through a little bit. So what in goodness name does a sextant, that's a sextant, have to do with any of this? So way back, 40 years ago, it's a long time, I got to be navigator on a guided missile destroyer in the US Navy. And I would say maybe, a third of this audience remembers that there was a world before the global positioning system. And you didn't just look at this thing to figure out where you were to within about 2 meters in the world. So I could actually use one of these still. I think I can. And one of the things you learn in navigation really quickly, at least if you want to keep your job, is look at all the data, but don't lock on to any one thing. And back over a decade ago, when the Navy asked me to really take a hard look at climate change, that's kind of how I approached it. I tried not to lock in, but look at everything. And I would also argue that scientific understanding, is kind of a three-legged stool. What does the theory tell you? What do the observations tell you? And can we predict it? Basically, can we get it right for the right reasons? I understand there's about 50 National Weather Service NOAA people here. I've done forecasting for nearly half a century. Sometimes you get lucky. Sometimes you get right for the wrong reasons. But you really want to be right for the right reasons. And if you can do all those three things, then I would argue we have understanding. So here's just a couple observations. And I like these ones because they have nothing to do with the thermometer. They have nothing to do with how we do or do not process data. They're just like what the plants are doing. So on the left is grape harvest date in Julian date. So low is early in the year, late is high in the year. And you can see this is back to the Middle Ages, back to the 1300s. Until you get to about the middle of the 20th century, it was pretty constant. Again, variation year to year, of course. And then all of a sudden, you see the warming and you see the early harvest. Similar if you go halfway across the world to Kyoto, Japan, this is the cherry blossom date. Anyone lived in Japan? So I lived in Japan for a couple years. The Japanese are fantastic record keepers, and they just know this stuff. In fact, as the cherry blossoms come out on national TV, they would tell you with each city that they bloom, is it early or late, and how it shows up. It's fascinating. But anyways, this is Kyoto. And again, you see the same thing. Julian date here, so early is low on the graph. Late dates are high on the graph. And this goes back to before the year 1000. This goes back to about 800. And again, similar thing until you get to the 20th century, stable, and now we see the cherry trees are blooming earlier and earlier. So I think these are two, half a world apart, nothing to do with people or how we do or do not measure or post-process data. This is just what the plants are telling us. Here's something a little bit more modern from my friends and colleagues at NASA. They have put together a rather nice animation, some of you may have already seen this, that really shows how the temperatures have changed by year relative to a 20th century average, basically a 20th century average. So if I hit this, hopefully it's going to play. So I'll play this twice. But you can pick, like either a place in the US or maybe your parents or grandparents came from another country. You can kind of see how that changes. The years are down basically in the South Atlantic, so between Argentina and then just to the south of South Africa. So here's the 70s, the 80s, and you can see as we warm, again, not every place warms at the same rate, and there's still year-to-year variation, but look at where we are now compared to the start. I'll see if I can play this one more time. Okay, here we go. So again, even back in the 19th century, you could find warm years in certain places. And in the 20th century, you can certainly find cold spots. There's the Dust Bowl. And the Dust Bowl certainly showed up pretty well in the southwest US, but globally, it wasn't that big a deal. Here's through the 80s, the 90s, 2000s, 2020, and it's almost all orange or red, except for that little interesting hole there south of Greenland. So if anybody's curious about that, we can talk about that in Q&A. Okay, so that's some observations. I talked about theory plus observations plus prediction. So the theory is on the left. And how many NOAA people do I have, Weather Service people? Okay, I should make you guys derive the radiative transfer equation, but I'm not going to because I'm nice. I'm not going to do that. But, this actually comes back, the theory starts in the early 19th century, 1822. That guy on the far left, bottom left of your screen, that's Fourier. So anybody who had the pleasure of taking calculus, it's the same guy. It's that Fourier. And he basically figured out that, hey, the atmosphere is a whole lot warmer than it should be, just if you looked at the sun. And then the guy in the middle, a Scot named Tyndall, he was the one who actually figured out that it was carbon dioxide. It wasn't oxygen, it wasn't nitrogen, it was carbon dioxide. And by the time you get to the guy on the lower right, Arrhenius, a Swede, he was actually doing stubby pencil to paper and did some of the first global warming calculations. Now, he thought it was a good thing, not a bad thing, but he was actually starting to figure this out. And that was about 1900. So you had a Frenchman, a Scot, a Swede. As far as I know, they did not go into a bar. But by the end of the 19th century, we basically had the theory there. So who considers himself a scientist in here? So what do you want to do? Do you want to write yet another paper that proves a science consensus, or do you want to have a revolutionary theory that in fact turns things upside down and is right and is subsequently proven? B, right? We all want that because they're going to put your name on buildings for the next 500 years. You're going to be an Einstein, a Newton, somebody like that, a Galileo. So many, 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 many scientists have really kind of scrubbed the basic theory of greenhouse gases. And all we do is we confirm and confirm and refine and confirm. So I know sometimes in some people it's like, well, you science guys, you're in some sort of cabal here to do this. It's like, one, a lot of people here in the government, right? So you all know we're not that good, We're just not that good to have some vast conspiracy like that. But two, all the incentives in the science community, in fact, are for disproving this. You will be famous for centuries, and we haven't done that. So how have the projections done? That's on the right-hand side. We could spend whole conferences just talking about the projections. But bottom line is these are models that were run 15 to 20 years ago. So now we have, in a climate sense, we have a couple decades. And you can kind of see that black line down the middle of the gray, and the gray is sort of the uncertainty, if you will. And then the red line is kind of like what happened. And do climate models on average predict year to year? No. Do they get the trend? Yes. And we've been getting this trend right for many, many decades. So I would argue that we do have theory and observations and prediction. And I would argue we have high understanding. Again, in Q&A, if people have science questions, I'm happy to take them. But to me, especially as we move forward to the impacts and so what are we going to do, the science, and this is meant no disrespect to people who are working science, and there are active pieces that are still really, really interesting, but the basic science is like really, really, really well known and actually not all that terribly interesting anymore. Okay, Who's read all 1,500 or 3,000 pages of that IPCC report that came out? Yeah, I haven't either. But here's kind of in one page what it says. And this is sort of what I've been talking about, right? We have just started to get on this escalator of, I'll call it extreme weather. And what we see now, which we think of as kind of like, oh my God, is going to be the good old days. And this is kind of, as I said, if you sort of took one slide out of their deck, this would kind of be it. Okay, and again, a point that I have mentioned a couple times now, but I think it's important, is you look at sort of, you can kind of see where we are just after 2020 here. That's the years are on the bottom axis here. And kind of where we are, so we're a little over a 1 degree world. I know that's a proxy. It's kind of this weird arbitrary thing we use, but we'll call it a 1 degree world right now compared to pre-industrial. No matter which of the emission curves we ride for the next 10, 20, I would say almost 30 years, we're going to get a similar answer, and all those answers are warmer than today, which implies more extremes than what we have today. Okay, so I keep talking about these extremes, and 1 degree, it's like, shoot, 1 degree, I mean, that can be a 5-minute temperature change. Who cares about 1 degree? And again, some of you may have seen this, and maybe it makes, it's like, oh yeah, you've seen it, but maybe not everybody has. So here's just on temperatures, and it's like, do we really care, like, if it's 65 or 70 degrees? Probably not. Not for most things, at least. But do we care how many days above 95? Do we care how many nights stay above 70 or 75 or above 80 degrees, and we don't cool down and the heat stress keeps building? Yeah, we do, and you can see how those extremes on the right side of this bell curve build, and they build much, much faster than you would think of just, 1 degree or 1.5 degree. So this comes out of my friends from Climate Central. I have asked them if they could build me a graph like this, but actually accounts for the nonlinear effects of water vapor, because you would see the extremes building even faster. This is just linear. The water vapor is increasing exponentially. Okay, worldwide disasters. This comes out of Munich Re. Probably, again, a lot of people have seen this. The reason I like this graph is that red line. If you can see those red bars down there, they're geophysical events like earthquakes and tsunamis and volcanoes. So how much linkage is there between climate change and earthquakes? Sort of a trick question. There really isn't, right? So we see those numbers in the last 35, 40 years really very, very stable. And that gives me some confidence in the way that Munich Re is counting, that they're not like commingling either more expensive property, more people, of course, on the planet. So they're really just counting events, 1, 2, 3, 4. And you can see these other ones, and there's, maybe a little bit of an arbitrary definition between how they break down meteorological versus hydrological versus climatological, 3 big words, but they're increasing. Another way, and I kind of almost like this next one maybe a little bit better, and it may be more relevant, especially to this audience here. How many days between billion-dollar disasters are we seeing? And this is U.S., in the U.S. So 30, 40 years ago, so any old-timers in here, let's say at the start of your career, yes, we had billion-dollar disasters, and this is adjusted for inflation, so that's not the reason it's going up. But there would be months in between them. You would have time to reset, to plan, to look at lessons learned, to say, okay, what worked, what didn't, let's fold that in. Look at the timelines now. We're down to a billion-dollar disaster almost once every 3 weeks, once every 2.5 weeks. Where's the capacity to deal with that? Just the simple physical capacity. Where's the emotional, where's the mental capacity to deal with this? Where's the financial capacity to deal with this? And I think these are, because otherwise this becomes like, yeah, we're going to do it, because I'll bet your community, like both the NOAA community, the Park Service, where I work now, Certainly the Department of Defense is like, can do, right? We're going to do it. Somehow we're going to do it. You're going to kill yourselves if you keep doing this, unless you can find either different ways to do it or more capacity. You know, flooding in Norfolk, here's just another example of that change. Okay, so those are some basics. And again, happy to talk more about any of this in the Q&A. How does it affect, you know, your group? So you may or may not have heard or even known that the National Academy of Science, in full disclosure, I chair the Climate Communications Initiative, which is one of the sponsors of this particular group. But we do these monthly climate conversations. And this one was on extreme events. So we had Marissa, a guy named Craig Fugate, maybe you've heard of him, probably. And Marshall Shepard, who is probably within the meteorology community as famous as Craig is within the emergency management community. They have a fantastic conversation. I have the link here, so if the slides get distributed, you can click on that, or you can Google Climate Conversations Extreme Events, National Academy of Science, and this comes right up. It's about 45 minutes. I would strongly recommend listening to it. I think it's a really interesting conversation. And I'll refer back to it a couple times here in a few slides. But here are some climate impacts that are coming up. And again, you can read faster than I can talk here. But these rain bombs, that's my name. These rain bombs, I think, are really dangerous because they just overwhelm an area that hasn't really prepared for this kind of rain. And we keep seeing this, right? We saw it in Germany over the summer. We saw it just in New York City with Ida. But we see it on much smaller scales as well. You know, small towns, medium towns, you know, up to New York City size. And you dump, you know, somewhere between 6 and 12 inches of rain on somebody in about 2 hours. There's very, very few places in the US that can really handle that without having damage, especially if it's populated, and of course we've paved over everything, and all the stuff that you guys know. The wildfires and tornadoes, how those seasons are changing. The graphic here is, I'll just explain this for just a second. This is how much the wettest of the wet, or technically the top 1%, is changing compared to, basically now, compared to where we're going probably in 50 or 60 years. So this doesn't mean that on average everybody gets wetter, but it means when it rains hard, it's going to rain even harder than we've seen. So again, remember, this is the good old days. 2021 is the good old days. So you can see in the Northeast, we could see up to 40% more cases of extreme precipitation. Same thing with the Northwest. Perhaps the southern plains, you know, they're only 5 to 10% higher. But everybody goes up. Nobody goes down, and some parts of the country go up a lot. You know, more capacity things. Let me just talk about the graphic for a second. You know, we're seeing, and this is a really interesting part of the science as to exactly why this is going on, but we are seeing the tornado, I hate the term tornado alley, but really where we're seeing frequent tornadoes changing, where that is. And we're seeing more and more, and not only are they more tornadoes, but more intense tornadoes down in the south. And they're particularly dangerous for probably reasons you guys know at least as well and no doubt better than I do there. So between housing, between poverty, there's some geographic reasons, much more trees, right? Harder to see them coming. You're not out on the treeless Oklahoma, or Nebraska plains, and more people. We got more people living down there. So this is interesting. I mean, just right now, anyone from Storm Prediction Center here? I mean, Storm Prediction Center has like marginal chance of severe weather in Pennsylvania, I think for both tomorrow and Thursday, and this is later October, latter part of October. This is not what we were taught in meteorology at Penn State back in the 1970s. This is not severe weather season, but here we are. So these are changing, and you can read the stuff again on the left. Interaction with other risks, so whether it's being COVID, future risks to come, how does all this work? When we try to build back or build resilient, how do we square that with a lot of communities wanting, needing to build back for their tax base? How else do we finance communities so that we don't keep doing the same thing again and again and again? Sea level rise. I realize I have these in centimeters, so let me translate for you. So anyone on the coast here, so basically think of about at least a foot, 10 inches to a foot by 2050, but if things break wrong, that could be 2 feet by 2050, so that's 30 years from now. By the end of the century, conservatively be planning for 3 feet, but if things are not good, that could be closer to 5 feet. So 2 to 3 feet by the middle of the century, 3 to 5 feet by the end of the century. I'm sure some consultant can, give you many more decimal points and, probably have a better tie and suit on than I do, and charge you a lot more money. But those are going to be the numbers, okay? Then you have to add the local effects, like is your land sinking or rising? Some things like the Gulf Stream slowing down, stuff like that. So if you're Norfolk, you better go on the high end and add 1 to 2 feet. But by and large, those are the numbers. So, that's a bonus, if you will, for living on the coast. We have those. I have seen a number of Coast Guard officers here. I think I've seen a couple active duty DOD from the services. So this is probably something that's going to become increasingly important. It's already important. But it's basically how the Department of Defense thinks about humanitarian assistance within the United States. And of course, we got to have an acronym, so we call it Defense Support to Civil Authorities. And since it's the DoD, it's not easy, right? And you've got all these chains of command and all this kind of stuff. I'm not here to give you a primer on DISCA, but I would recommend if you're in a management position that you know how, or you attend a course on making sure that you know how, or find your local guards guy who actually knows what's going on and buy him a couple beers and make sure that you know how to tap into that support. Because it's probably going to become more and more important. That picture in the middle right is actually Air National Guard fighting some of the big wildfires out west. So yes, the DoD gets involved in a lot of humanitarian support overseas, but we also get support of all kinds inside the United States. And there's a pretty defined process for how to do it. And I just recommend that you're familiar, you brush up, because when bad things happen, you may rapidly go through all your resources and you need some other help there. Okay, so this slide here shows you why I became a meteorologist and not a graphic artist. But if you think about it, and I'm sure, and again, somebody can make a PhD out of this and do 5 years of study and write 200 pages and all this kind of stuff. But it's sort of interesting to see, like, why are some extreme events sort of seared into our head, and others can be pretty extreme events, but it's like, yeah, that was bad, but we sort of dust ourselves off and we go on, and within a month or so, we don't really remember them. So I would argue understanding thresholds is pretty important, and different communities, different areas of the country for different parameters, whether it's fire, whether it's drought, heat, flood, we have different thresholds. The sort of the classic one I used to use was Sandy and the subways. I guess now I can still stay in New York City, but just this summer, it's like if you put enough rain on, the basement apartments flood, right? But if you have just a little bit less rain, the basement apartments don't flood, and many of those people would still be alive. So we have a threshold. Do you exceed the threshold or not? And if you do, what is the response? In Syria, the response of the Assad government to drought 15 years ago was basically whooping up on his own people and made a bad situation much worse, I would argue catastrophically so. And then what's the society response to all of these? You know, how cohesive is the society? Does the society see that help is on the way or not on the way? Or it's like, hey guys, deal with it yourselves. Or, we're actually gonna try to exploit it. So all of those things together determine the ultimate response there. Is this seen as fair? Is the response seen as fair? Is it equitable? Is it just? I think those are a little squishier, if you will, a little softer, but I think they're no less important. So this is kind of how I look at, yes, we get an extreme weather event, but just because we get it doesn't mean that we're either going to have this catastrophic collapse or sometimes relatively small ones if we exceed thresholds and we have a really, I guess technical term would be crappy response, then you can get a disproportionate society response. The migration, both internal within the U.S. as far as external, I think is one of the biggest challenges that we're going to have, and it's going to impact everybody. And again, when I look at the literature, they're not even to within a factor of 20. How many people? 25 million is not great. 1 billion is like, oh my God. 200 million is a ton. Just for reference, out of Syria to the European Union a few years ago, that was about 1 million refugees. And you could argue there was a climate component to them. I'm not going to call them all climate refugees, but there was a climate component. And I would also argue, I think I'm on pretty solid ground, that shook the EU just about to its core. That was 1 million. So if we're starting to talk even 25 million over some period of time, where are they going, and how does this change things? And within the US, we're going to see climate migration too. We are seeing it. I like this quote from Craig. There is nothing managed about managed retreat, and I think he's got a good point. But we just sort of keep doing the same things. We sort of have these meetings in different towns, and we kind of say, oh yeah, we're gonna protect all of you, but we don't. And then the folks who aren't protected, usually again, those disadvantaged people, what are they left to do? They're left to kind of fend for themselves. I would not call that was a managed retreat. Just one other thing that we're seeing, and this was a New York Times article from, I guess, about a month and a half ago, bankrupting small towns. So I've just, didn't come out in the introduction, but I work for the Park Service now. So we worked in Grand Teton, we were down in New Mexico, and we basically took the old Route 66 all the way up here to Michigan. And I can tell you there's a whole lot of towns that are just kind of hanging on, if they're even hanging on anymore. And they take one or two of these hits, and that's it, without help. And you have desperate people, right? Remember my fantastic graphic arts slide from a couple slides ago. What's that response? So what happens here when we, when we have a whole bunch of desperate people, honestly, and this is not, politics 101 or whatever, but how does that feed into the nation's political discourse? And is that in our collective interest? And I think those are questions worth asking. Okay, so what to do? So this is, yes, admittedly, kind of a DoD slide. But how much preparation and thought can we put to left of the event, before the event? Okay, we're really good. I mean, I've seen your community in action on the response side. We're really, I'm impressed. We're really, really good. How do we make sure, and again, it may not be, in fact, it almost certainly isn't just the emergency management, but how do we get the right folks to be working so that you, collectively, your profession, doesn't have to do as many heroic things on the response side, and that we do correctly incentivize so that the next one, and hopefully by now you've seen how much more next there's going to be, is more manageable. And I think that's really worth thinking about. I think that's where the money is to be made, is sort of on the left side of the events. These regional climate assessments, I think they're really, really helpful. It's pretty easy on the national side, and this is, you can see Greater Yellowstone. So again, this is where I work in the summer, and I'm working with Grand Teton to help them think through climate, the Park Service up there. And if you look at the averages, let's say for precipitation, if you look at the climate projections, they really don't change much. And it's like, okay, it doesn't change much. If you look at the distribution, there's huge changes. We're probably up there, when I say we, the Tetons, Yellowstone area, it's probably going to get more precipitation in spring and fall, less in the summer, hotter in the summer, and the precipitation that falls on the shoulder seasons, spring and fall, is much more likely now to be rain rather than snow. You add all that up, and that has huge implications on the ecosystem, on the animals, on fires, on the tourists, which is a fundamental part of their economy. So if you just looked at that annual average, you would say, meh, whatever. When you start digging down and what these regional assessments can give you, that's what you get. So the pictures on the side, that's what I do in the summer. So we can talk about that in Q&A too. That's actually a lot more fun than climate stuff. Managing bears. Okay. In the Navy, I used to tell the folks who worked for me that, if the boss is interested, that makes you, few people know this, fascinated, right? So we're starting to see that. We're certainly seeing that in the Department of Defense, but we are seeing that the president has made one of his three things getting ready for climate. Now, of course, it's got to go through the political process and all this sort of thing, but it will come down to whether it's through Department of Homeland Security and through other ways that we're going to try to be more serious about this. And as I said, I started the Navy's Task Force Climate Change in 2009. There were some good intentions, but honestly, it's been a lost decade, if I'm just honest, okay? So we're going to see, hopefully, this next decade is not a lost one. I mean, if you're an aviator, what are two things of no use to you? Altitude above you and runway behind you. Think about that the next time you're on United. We have put a lot of runway behind us on this issue. Hopefully, we will stop doing that. Yes, the science is going to get better. We kind of add about 1 day of skill per decade. It'll be interesting to see whether that changes for better or for worse, but how we talk about this is probably a lot more important now than some of the actual predictions. And I would argue, I know, it's not exactly a communications paradox, but we're getting close enough to Thanksgiving, I just have to use the graphic there. We do sort of have this paradox. So I've been talking about these extremes, and I personally have witnessed them. You saw that on the first slide. But a lot of people haven't personally seen it. So what we hear, and you hear way more than I do because you're in the field, is I had no idea. We've never seen this before. I've lived here for fill in the blank, and we've never had this. Yes, we heard the warnings. Yes, we heard whether it's particularly dangerous something or there was an emergency. I wasn't sure if they were bringing back the 70s TV show, but there was some kind of emergency. We heard all that, but I didn't really think it would be that bad. And boom, and then they're either dead or they're wiped out. I talked to a lot of people after Katrina. We heard the same thing, but that was really, we just keep hearing this. So how do we do this? And I say we. I know there's a lot of NOAA people here. I personally don't think this is exclusively a Weather Service issue. It's not exclusively an emergency management issue, but it is going to be all of our issue of how do you motivate people to do something for something they have never personally experienced. That is hard, right? We know that's hard to do, and I don't know if there's going to be one aha thing or if this is just going to be sort of a lot of incremental stuff that helps us get there, whether it's carrots and sticks or whatever. Okay, final thoughts, and then we'll go to questions. There are some surprises still to come. This middle one, this climate intervention, or you could call it geoengineering. If these extremes get bad enough, does the world decide to do this, or does an individual country decide to do this? Because you can do some of this stuff relatively cheaply, a few billion, and you can significantly change the climate. I was on this committee, and what I would tell people like congressmen and women is you don't roll the climate back with, let's say, solar radiation management. There's nothing managed about that either. But you do turn the climate sideways. So that may be yet another whole set of issues to deal with. The guy on the right, Niels Bohr, I put him up there because we all know that predictions are hard, especially when they're about the future. Okay, so I've mentioned this a few times. We started with Waveland. I'm going to end with Waveland. So again, little tiny town on the Gulf Coast. Anyone from Mississippi in here? Okay, at least one. So you know where Waveland is. And you might have been there and dealt with some of this. So this is a picture I took, the top picture, a few years after the storm, after Katrina. And I know Katrina's old now, but it's my reference point. So you see that for sale sign? That's my lot. That was my mitigation strategy. I'm going to find the greater fool theory, somebody else, and somebody did buy it. They were from Houston. I thought there was some irony there. They bought it, and the people immediately, so go down to the center. That house was rebuilt at exactly the same elevation because they know it was an act of God and it's never happening again. That's what they told me. And then the guy on the corner there, that's the neighborhood plumber. Mama didn't raise no fool. So he's up at about 30 feet, 25 feet. I don't have the heart to tell him that those little tiny pilings, when you start getting a debris flow through there, but he thinks he's safe. So this is how we're managing this right now. Every person for themselves, everybody's doing their own thing. There was no federal buyout, there was no federal plan, there were some attempts at plans. The people said, we're just going to build back like we were, and they kind of did. I'll just close with this. And I like this quote. This is Admiral Nimitz talking to Admiral Halsey. It's probably kind of a one-way conversation, and Nimitz is asking, why in God's name did you drive your battle group through a typhoon? And you lost 3 ships and 700 sailors. So while Nimitz's quote was in the context of a specific extreme weather event, I think it applies to extreme weather in general and to climate. And taking precautions is what we need to be thinking about because otherwise really, really bad things happen. And with that, I will end here, and I think we do have some time for questions if you would like some. Thank you. Okay, so I am taking in this conference that when somebody stands at a microphone, they have a question for me. Sir, if you could let me know your name and affiliation, and I'll try to answer.
My name is Rocky Lopes. I am serving on the NOAA Science Advisory Board, Tsunami Technology and Advisory Panel. I serve as a co-chair, and Mike Ango told me to tell you hello. We are writing in our report to Congress updated report, and we're looking at, and I would like your opinion on the relationship between sea level rise related to climate change and how it may impact or cause further damage that tsunamis may cause on U.S. coastlines, and what can localities and states and territories do to mitigate the impact of the potential increased damage from tsunamis that may occur in this relationship. So what is your opinion on that matter?
It's a great question, and the first thing I will need to say, with no pun intended, is I'm probably out of my depth since I have done very little on tsunami or sort of that extreme surge. But a couple things would sort of come to mind. Can we find cases around the U.S., maybe not for tsunami, but for significant storm surge where we believe communities or localities are really doing the right thing? Because I mean, physically, right, a tsunami in some ways is just this storm surge on steroids. And no, the waves are period different and stuff, but we have that. Are there international, and of course you think of Asia, but are there, whether it's Japanese, Korea, are there international best practices that would be useful for us? If I was looking at I don't know, and I'll make up a number, and maybe I'm being laughable here, but let's say a really bad tsunami, a 10 to 15 meter tsunami, would that be bad? So if you add that on, does that sea level rise, let's say for the rest of the century, of plus or minus 1 meter, whether you have a 14 meter tsunami or a 16 meter tsunami, are you, as a low probability, very high impact event, are you going to really plan much differently for any of them? So in that sense, if I'm really looking at major tsunamis, honestly, the sea level rise is probably now a secondary factor. If I'm looking at minor tsunamis where the sea level rise could be, let's say, 50%, then yeah, I'm going to consider it. So I don't know enough about sort of the extent or sort of the magnitude of tsunamis that you're planning on, but that's kind of how I would approach it, if that helps.
Thank you.
Thank you.
Hi.
Yes, ma'am.
My name is Suzanne Blake, and I'm wondering if you can tell us about the blob below Greenland.
The
blob below Greenland in your slide.
The blob, okay.
Yes.
I'm 2 for 2 now in asking, in seeding that. So my colleague at Penn State, Mike Mann, and many others have done some work on this, but what we're pretty sure, and I know we've got a lot of people in here, maybe some who have studied this quite a lot or have done active research on it, and if so, raise your hand and tell me where I'm all screwed up on this. But basically, as we melt more and more of the Greenland, the ice, of course, is melting, and that becomes fresh water, right? So it's still really cold, but it's fresh water. Fresh water, less dense or more dense than salty water? Less dense. Okay, so what happens is where that little blob was south of Greenland, that was one of the places where when we had the salty water, let's say half a century ago, whatever, Greenland wasn't melting as much. You get all the cold air coming down, you have the Gulf Stream coming up, so it's not ice, but we really cool that water down, and it has a high salt content. So very cold, salty, so it goes all the way to the bottom. Okay, it just goes all the way to the bottom, and it's sort of one of the drivers of the big ocean conveyor belt, if you will. Now, when we put more fresh water, relatively fresh, diluted, if you will, yes, it's still cold, but it's not quite as dense, so it tends to kind of sit on the top and doesn't go all the way down, but it's still really cold. And we see that. That's, as I understand it, kind of where the science is. I think there's still a lot more to be learned about this. Is it, the details of can we predict any of this? Is this even the right theory? So I wouldn't bet my career on it, but as I understand it, that's kind of what's going on. It's just sort of interesting. We have this blue blob that's really being quite consistent now. South of Greenland, whereas the rest of the northern hemisphere gets warmer and warmer. So I don't see anybody in stitches rolling on their side that I screwed that up totally, but I'll bet somebody in here is working on that, and they may be able to give a lot better explanation than me. Sir.
Yeah, good afternoon. I'm Preston Wilson with FEMA National Dam Safety Program. Just here in Michigan last year, you had two dams fail. And infrastructure in this country is getting older and older. All right, the average age of dams are about 60 years old in this country. So that and extreme storms don't match together. So and my question is to you is how does the engineering community, the emergency management community, and the meteorology community kind of get together so that the consequences behind these extreme storms isn't exaggerated by what man has made.
That's a fantastic question, and you're absolutely right. I mean, what was it, about 12 years ago now, 13 years ago, we did all these stress tests, right, on the financial system. That was kind of the word of the day in Washington, at least. We were going to do stress tests to make sure that banks don't fail. You could argue that whether it's through the engineers and emergency managers and just local knowledge, which dams, it's like, hey, these are either old, or we see they're getting at or near their design life, or we've just, seen issues that they could go. This would be something in which one, ideally you could model. You could sort of put kind of 6 inches of rainfall or a bigger ring, sort of move one of these big wet tropical storms over and see what happens. What are the breaking points, so that everybody would know, and if we start seeing those forecasts, at least we can get people out of there safely. But ideally, we use it to prioritize a list. What you bring up, sir, I think, as I was thinking about it, and again, my bias is I've worked a bunch with the National Academy of Science, Engineering, and Medicine. This would be a fantastic study, probably led by the National Academy of Engineering, but bringing in those groups that you mentioned, and really, it's a report, but we do know that sometimes these reports, you've got to have the analysis. You've got to have the solid analysis. You still got to sell it, but without that analysis, it's hard. And the National Academy of Engineering could really be that foundation. And I would think Department of Homeland Security, possibly NOAA. I love spending NOAA's money now. I'm not part of them. And some others would be willing funders of such a study, because, yeah, I mean, it's catastrophic, right, when these dams fail.